All right, hello class. Welcome to this homework video on 1.4. So we're going to go over the four problems we have on the homework assignment that are related to stem plots. So let's get started. The first question, which is number 2 from the textbook. So we're talking about high temperature readings in degrees Fahrenheit for Phoenix, Arizona for each day in July of 2013. So we got a bunch of high temperature readings. We want to make a stem plot from this data. Do not split any stems. Okay, so first off, we want to figure out what the smallest stem is. So we have, the stem on the left side. We have the leaf on the right side. We have to have some kind of key, remember, for this. So the smallest stem here, or the smallest number in general, smallest number looks to be about 84. Okay, so 84 is our smallest reading. So our smallest stem is 8. Then we have a stem of 9. We have a stem of 10. We have a stem of 11. And remember, they don't want us to split any stems here, so we'll stop there. We'll do 8, 9, 10, and 11. If they wanted us to split stems, then we'll have to have 2 8s, 2 9s, and so on. Extra stems, basically. All right, so let's go ahead and start with the leaves. So for 84, we have a leaf of 4. Now let's start with the 9s. So for 9, we have a 93. We have a 97. We have two 99s. And it's good to cross these out as you go. So it'll be easier to find numbers that way. So hundreds, we have tons of numbers in the hundreds. So the smallest number, we have a 100. We have a 101. Another 101. 102. Another 102. 103. We have 104. Another 104. 105. 1, 2. Found another 104 here. So we said we had two 105s. 106s, 2 of them. Another one right there. 1 107, 2 107. We have a 108, 2 of them there. We have 109, a couple of 109s. And so now we're in the 100, in the stem of 11. So we have 110. We have 111. We have 2 of them. We have 113. And we have 115. So it looks like we have all the readings. And so looking at this, looking at these readings, it appears that we do have some kind of outlier, of 84, really, really low temperature. So we do have some kind of outlier. Without that outlier, if we were to remove that outlier, we would have an approximately, symmetric distribution. But with that outlier, it seems that we have a distribution that is skewed to the left, okay? Just looking at that shape, with that tail, long tail there, and a peak on somewhere on the right side, that seems to be what we have. Okay, so that is our stem plot for the data. So here they want us to use stem plot for this data, but using split stems. Oh, let's go back to the problem here because we need a key. So make sure that when you do this, that you have some kind of key for your stem plot before we move on to the next one. So let's pick any number on here. Let's say we have a 9 and a 7. So a 9 and a 7, so that stands for 97 degrees Fahrenheit. So that's 9 and 7 is the high temperature reading in degrees Fahrenheit for Phoenix, Arizona. for Phoenix. Arizona on a day in July of 2013. Okay, so just kind of include a description there. All right, so for this second one, we want to use split stems here. So let's go ahead and let's do the key right away before we forget. So for the key, we know that we're going to, so let's pick a number. So if we take a number like 8.3, for instance, then we can say that, let's say 8 bar and a 3. So that 8 bar and a 3 stands for 8.3. So, and what does the 8.3 signify? In this example, it says the data give the protein content of different varieties of beans in grams per 100 grams of cooked beans. So 8.3 represents the protein content in a particular reading here. Okay, so there are 31 beans here that we're looking at, and they're looking at the bean content or the protein content. So 8/3 represents 8.3 grams of protein per 100 grams of cooked beans. Okay, so 8.8/3 represents the protein reading of a particular variety of beans of 8.3 grams per 100 grams of cooked beans. Okay, so something like that. As long as you elucidate the concept, then you'll be fine. Okay, so now we want to do a stem plot with split stems. So we have a stem and we have the leaf. So the smallest reading here is 7. Looks to be about 7 in the 7s. So 7.1. Oh, actually 7.0. I see a 7.0 right there. So remember that when we do this, when we split the stems, we have two. We basically have 2 of each type, right? So we have 2 of each stem per se. So we have a stem of 7, we have a stem of 8, so we have 2 of those. Oh, we do have a 6.8. I didn't realize that. So we do have 6s there. So let's include the 6s. And then we have here 9s. So 9, we have 10 for a stem, all the way to 16, really. Now, here, because we don't have any 12s, any 13s, or anything like that, I'm only going to write them once. I'm not going to write them twice, okay? And for the 11, or for the 10, this should be a 10 right here. For the 10, so I'll write that twice here. But for anything after that, until I get to the 16, I'm only going to write once, okay? But it doesn't really, there's not going to be, there's no way that I can split those stems if there's nothing to split, right? So something like that. And then we'll go ahead and get started. So really, you don't have to split the 6, but I will just for, just to kind of show you. Remember that the first split are the numbers from 0 to 4. And there are no numbers from 0 to 4. So we only have 6, 8 there. That gets rid of the 6.8. For 7, we have 7.5, 7.1. All right, so we got to go from 1 to 4. So, or 0 to 4. So we have 1 there. We do have a 0. I didn't see that. So 0 and a 1. And that's it for that one. So there are no other ones. So now we're going to move on to the next split stem of 7, which are the numbers 5 to 9. So we have a 7.5, 2 of them actually. We have a 7.6, 7.7, 7.8. We have another 7.8. And that seems to be it. Okay, so I'm going to go ahead and pause the video and I'll fill in the rest of the entries to save you a little time. All right, so we have here, so I went ahead and fill in the rest of the data using the numbers that we have here. And we have a stem and leaf pod that looks about something like this. So just kind of illustrate the point in the final answer. So it looks like, you know, there are definitely outliers here with the 16.6. And if you look at the distribution, it looks like it's skewed to the right in this example, just by looking at that data. And looks to be that the center of this is, you know, around here. If you were to look at the center, so in of the distribution, it's usually where that peak is, where most of the data is clustered about. Okay, so that's about the center. They're not really asking for a description, just to actually make the stem plot. All right, so for number 6, here's a stem plot that uses split stems for the daily high temperature in Phoenix. So basically the one that we looked at earlier with this, but now it's a split stem. So if we look at the data that we did for high temperature, this is how it looked like, you know, without the split stems, right? And so you saw that there's a lot of numbers for the stem of 10. But then when you actually do it like this, it actually spreads it out nicely. And you can actually see, you know, more of a distribution here. So in this case, so it says 1% of days in this month were hotter than 100 degrees Fahrenheit. So we're looking at for 100, so it has to be hotter, so it has to be greater than 100. So that means 101 and so on. So that means these numbers will be counted, and all of these numbers will be counted, basically. And so in this example, what we're just counting them, right? If we counted them all, 1, 2, 3, 7, 8, there's 8 here. It's 20, 21, 5, looks like 25 readings here. And so there's 25 readings that were hotter than 100 degrees Fahrenheit. So what percent? So it's going to be 25 out of, in this case, there are 31 readings, and then times 100. And then you get that as a percent. So just convert that as a percent using a calculator. So if we describe the shape of the distribution, well, then we can see that if we look at that, it looks to be about skewed to the left, but not by much. Like if you look at the 84, and if you were actually to not even include the 84, you could say that it's symmetric. So you know, if it wasn't for that 84, it would probably be more skewed to the left than it actually is. So we could say slightly skewed to the left, or if you would like to say approximately symmetric, then I would understand with an outlier of 84. That's okay. But we'll say slightly skewed left. Just because it does have that longer tail on that left side. Okay, which valley appears to be an outlier? So clearly the 84 appears to be an outlier in this example. And if it wasn't for that, we would actually have more of a symmetric distribution. So give the stem plot a key using this value. So then if we were to use the key, so 8/4 represents, and we kind of did something like this, but it represents the high temp reading in degrees Fahrenheit of a day in July of 2013 for Phoenix, Arizona. Okay, and that's our key. All right, and then this is the last example. I believe we did this in class, but I wanted to make sure that we have an idea of how to do this, just in case you forgot. So we have the number of points scored by teams in a couple of different divisions for the basketball playoffs. And so we want to make a back-to-back stem plot for this. So when you make a back-to-back stem plot here, we have Division 1, Division 5. So we know we have two, you know, groups that we want to compare. And so we look at the stems. So the smallest stem, that's 46. And then we have, oh, well, we have 37 here. So we have a 3 all the way to probably in the hundreds or close to it. Yeah, 106. So 3 to 10 essentially. Okay, so then so for division 1, if we were to go to division 1, well, we have a we actually have a 38. So 38 right there. We have, that's it for the 30s, I believe. Then we go in the 40s, we have a 41. We have two 47s. So 41 and two sevens there. So 41, 47, 47. And there are no 40s. There are no more 40s. And you keep going until you do all the Division 1, you know, games. And so then you go to Division 5. So let's do a couple examples from there. So for Division 5, we have a STEM 37, 37. So we'll do that. Do we have any in the 40s? We have a 45. We have a 44. Another 44. And that's it. And in the 46. Okay, and then you repeat until you get the rest of the back-to-back plot. So I'll stop here and pause for the final result. All right, so this is the completed back-to-back stem plot here. I went ahead and adjusted some of the values because I forgot some numbers there, so you can make any adjustments there. But this is the back-to-back stem plot. You can see that you can compare them side by side. And so that's it for part A. For part B, in which of the two divisions did the team score more points in their playoff games? Justify your answer. So we basically are comparing the center. So if we look at the center for Division 5, it seems to be that if you look at the distribution, most of the points seem to be, in this region, right? So it seems to be in the 60 to 69 point region, maybe, around there. So most of the points seem to be around there. And then if you look at, let's see here. Okay, so in which did they score more points? So they're not saying like on average, I guess they're just saying, which scored more points in general. Okay, so if you look at Division 1, they really had 106 points in that game. So again, a pretty high number of points for that playoff game. Okay, so what we were saying, so if we look at the distribution, let's kind of look at both distributions. So this one looks to be something like that, right? If it wasn't for these outliers, this would be roughly symmetric, okay? But because of the outliers, it skews it a little bit, but not by much, just looking at that. And then if you look at this distribution here, it looks like something like this. So here, if I kind of do this, but if you look at it, if you kind of guesstimate, this looks to be roughly what we call uniform. There are little variations here and there, but you can kind of see there are a couple of peaks here, and here. But if it wasn't real, if those were a little bit smaller or a little bit larger, they'll be roughly about the same. But in any case, if we were to do part B with the more points, if you look at the distribution, if you look at the data, well, there are a lot of 90s in here. Even though there are a lot of 60s, there are also a lot of 90s, and these higher points, these higher scores will actually make the average greater. So Division 5 looks to be the division that has the most, a higher average compared to Division 1. Now, if you look at Division 1, there are some outliers, 106, but there's only one of those outliers. Whereas most of the data seems to be in this general vicinity. And therefore, Division 1 seems to have he seems to have scored a lower amount of points on average compared to Division 5. Okay, and so that's basically us justifying our answer. Division 1 definitely has more games in the 90s compared to Division 1. Are the shapes of the distributions scored similar or different? Well, the shapes are different. The shape of Division 1 is slightly skewed. In this case, it's slightly skewed to the right, so we'll say slightly skewed to the right. Slash approximately symmetric. Because if it wasn't for the outlier, it would be approximately symmetric. So if you said either one of those, I would take that. It's approximately symmetric based on the distribution, just with a couple of outliers. But it's really not that it's really not that largely skewed to the right. Whereas Division 5 is kind of all over the place, but for the most part, we could say it's approximately uniform. Approximately uniform. Some of these points, some of these values can be a little bit larger, some of them can be a little bit smaller, and then they'll be about the same, just because there's so many things going on. And then there's a few peaks here that are going on Division 5. So the shapes are definitely different. And the spread is different because Division 1 has a spread between the 38 to 106, and then the spread is only between the 30s and the 90s. Okay, so the spread is different as well. So Division 1 is more spread out. All right, guys, that's it for the video. I hope you found this useful, and I'll see you in the next one.